things on network. First thing is, when you go from 1 gigabit to 10 gigabit, you will not get 10 gigabit performance. There are things that you have to do to get 10 gigabit performance. I've put a link here to Gareth Coates in the UK, ATS. He has a really good PDF about 10 gigabit Ethernet. I also was at a presentation last week from a gentleman named Alexander Paul, who has a great presentation on demystifying 10 gigabit performance, where he actually shows how to get as close to 10 gigabit as you can and what the overhead, etc. is. That's very good for basically explaining exactly what it is you need to do. When you run with the network, if you run a netstat-v, you're going to be looking for a number of different things. You're going to look for how much am I queuing. So for instance, here you see my software transmit queue overflowed 9,522 times. This is since boot, but let's say I rebooted an hour ago and I got that number. Then I'm going to go and I'm going to look at increasing the adapter transmit queue, which is going to be a CHDEV on the adapter. So I'll do an LS80TR, see what it's set to, and so on. For SCAs, you're going to change that on the underlying adapters for the link aggregate. You'll look for receive errors. You're going to look for transmit errors. You'll look for DMA underruns and overruns, all those kind of things. I have a note in here about the Lparstat space 2. Network performance is affected by entitlement. So it's another reason why you want to be careful that your entitlement's not too low. If you run an Lparstat, and that should be a lowercase l, space 2, what you're looking for is very high virtual context switches. What that means is that your entitlement's too low and you're spending an awful lot of time getting context switched out and back in and so on. And then one other comment, which is DB2 and Oracle oriented, there's a parameter called TCP no delay. It's an NO parameter. Sometimes it's called TCP no delay ACK. What that's about is that when I send you a network packet, the first thing you do is you send me back an acknowledgement. But you don't just send the ACK back. What you do is you go, you know, I don't want to do too much traffic, so I'm going to wait 200 milliseconds and I will coalesce all of the packets that I have to go to you and I'll send them after 200 milliseconds, whatever I have, including the ACKs. When you enable TCP no delay, it says I'm not going to do that. As soon as I have an ACK to send, I'm going to send it. So what that means is that you will have more network traffic, but you will have faster performance, and that's the trade-off that you make. So this is one I suggest to people that they try, but they try it by itself. It is a dynamic parameter. You can reset it immediately if it causes you a problem. And I wouldn't do it if you're already tight on bandwidth on your network adapters. But if you have bandwidth on your network adapters, this is very heavily used by people who are running Oracle and DB2 to improve performance. And again, I have the comment about checking error report. This is an output from an entstat-v on a shared Ethernet adapter. And the thing I want to point out down here is, if you look, you see in red, the no resource errors, 286.155. And I have a comment about, you know, check those tiny, etc. buffers. So when you see this no resource errors, it typically matches your packets dropped. And if you go down to the VIO Ethernet LAN-specific statistics, you'll see hypervisor receive failures. And all three of those numbers match. Typically, what that's about not having enough memory or buffers to clear the buffer space for a workload. So I mentioned the tiny buffers. So under the virtual trunk statistics, you'll see receive information, receive buffers. You'll see min buffers, you'll see max buffers, and you'll see max allocated. And what you're looking for is, for instance, you see here that my max allocated for my small buffers equals my maximum buffers. That means that I was growing from what I normally had, and I hit a cap. So if you see that kind of thing, you're going to want to increase those buffers. And you would basically do it by doing a CHDEV on the virtual Ethernet of the SCA. And in this case, I'm going to increase min buff small to 2048 and max buff small to 4096, so that I start with the appropriate number of buffers, and I'm not forever, you know, trying to get more buffers and not having enough, which slows down my network and which causes me to drop packets. So that's what those actually mean. And so that's something that you do want to look at. And I see these all the time with SCAs, so it is something you're probably going to have to adjust. This is just an example of the Lparstat output and showing you the virtual context switch setting, which is this little one just here. So again, this is something you'd want to grab in your typical baseline and then just compare it for when the system's running normally. This system wasn't doing much, but I just put this in here to give you an idea. One other thing I want to mention for those of you that are running Oracle, and actually this does apply whether you're running other systems as well. When you're using concurrent I/O is where I typically see this, and I typically see it as an example with redo logs. In Oracle, a redo log needs to have a 512-byte block size. That's because the application is writing 512-byte blocks. By default, file systems are 4K. So what happens is it tries to do the I/O. It tries to write a 512-byte block, goes, oops, need to redo that because I really need to do a 4K block. So it redoes the I/O. We call those demoted I/Os, and they're very, very expensive. You can see this with an application if someone hard-coded a block size in the application, and the application wants to write, for instance, 1K blocks, but the file system is 4K. Where I typically see this is with redo logs because they write a 512-byte block, and if you don't put them in a file system that has 512, you'll see a lot of demoted I/Os, but you can see it with applications. This causes a lot of kernel CPU, so it'll show up as %system, and it causes more physical I/O. If you're JFS2, I've put in here the command to do a trace. You notice I'm only sleeping for 2 seconds. That's because if you have this problem, you'll have a lot of them in a short time. If you do a sleep 2 and you don't see any, then try a sleep for maybe 30 seconds and so on. It does run a trace, which has a little bit of overhead, but if you have demoted I/Os in your system, you want to get rid of them. You'll see I use the LSFS-Q, and you'll notice that I've highlighted and read the block size there is what you're looking for. So if you know your redo log file system is U99 or whatever, you want to make sure that that block size is correct. A few other things, checking I/O bandwidth. If you want to figure out what your I/O bandwidth is, unfortunately you have to do work. What I did is I took the data from an NMON report, put it into a spreadsheet. So I took my disk read and write kilobytes per second and summed them. I also took my fiber adapter kilobytes per second, read and write and summed them. Down the bottom I total all my fiber channel adapters because it happened that FCS 0 through 3 were all on the same adapter. So I converted to megabytes, and I basically have the totals down the bottom for average and peak, and then I can compare those to what the known sustained and peak numbers are for the various adapters to make sure I'm not exceeding them. Unfortunately, that's not, you can get some of the data out of NMON, but some of it you have to put in a spreadsheet in total. I just wanted to show you that this is the kind of thing that you can do from an NMON report that can be helpful in helping you determine if you're okay with bandwidth. You could do a similar thing for the network. You just have to sum up the reads and writes and so on. Now we get to a point where we're ready to open a PMR because we've done all our diagnostics, etc. The first thing I recommend is open it through the web. You have to log in to do that, but it's well worth doing because it allows you to put in the full description, and you don't have to talk to level 1 who may have a hard time understanding you. I always have a tough time because I have an accent. It doesn't matter what I say. When I go read the PMR later on, it's like, that doesn't quite match up with what I said. Also, if you open it through the web, you can then follow the PMR. You can log in and check it all the time. So you're going to gather the documentation. You've got to put a clear description of the problem in. You've got to include any error messages. And they're also going to need serial numbers because they're going to go and check you for entitlement. You want to make sure you have current SWAMA, etc. before you try to open a problem, because having been sent to entitlement hell, it can delay a problem big time if you call in a problem and they go, well, we don't see that you're entitled. And there is a link, which I think I have later on, for actually checking what your entitled software is and what your SWAMA status is. To open a software problem right now, you go to the service request link. To open a hardware problem, it's a different link. They are planning on combining those. I don't think they have yet. One of the things that I see when customers have an issue is they don't set the severity. And one of the things that's nice about opening it via the web is you get to set the severity. I've told level 1 before this is a severity 2 problem, and then I've gone back and checked and it opened as a severity 4. If you allow it to default to a severity 4, that is a documentation. You may never get an answer on it. Severity 1 means that you're hard down, you're on call 724, and that you're willing to do what they call follow the sun. So with a severity 1, at 5 o'clock when whatever the East Coast shuts down, they hand it off to somebody somewhere else in the world that can handle it for the next 8 hours. This has to be a production hard down, and you have to be willing to be on call 724 and make changes as requested. You should still question changes if you don't think they're right, but just be aware that's what it means. Severity 2 means that production is severely held back, and and you don't necessarily have to do follow the sun. But I just want to make sure you understand that distinction. And then I have the link in here for uploading files to IBM, because it's a good thing to go read that so that when the time comes that you have to upload files, you actually know how to do it.